Good evening, good afternoon, good morning, everybody. Thank you for joining this streaming webcast with VM Underground, and hopefully we'll have a great conversation. As you can see in the slide next to me, this is called Load Balancing VMware Horizon Look at 3 Use Cases. My name is Frank Yu. I'm the Principal Application Experience Architect at Kemp Technologies, the load balancing company. And I'm here to give you hopefully some good, interesting technical information on VMware Horizon and load balancing, why it's done, how can you get it done easily, and what are the different models. As you can see, there are 3 use cases. And real quick, before I get into the slides, I want to talk about why do we care? And I think a lot of you know, some of it's fairly obvious. I mean, number one, VDI, virtual desktop infrastructure, doing this remote distance access for work is becoming really important, especially in 2020 with the pandemic, COVID-19, all these other things going on. Accessing work resources from home, from other locations, hotel, whatever the case may be, is really becoming a mission critical thing for businesses and business continuity. So we really want to go through and figure out how can we make sure that this scenario is available, not just as a, well, that's nice to have, because we have people sometimes working from home to where, oh my gosh, we have to have this because now 95% or 100% of our people working from home, and if they don't access it, our business is not doing anything. So let's go through this presentation and look at some of these use cases. And let me go to it. Here we go. And flip to my next slide here. And first, again, why do we load balance VMware Horizon? And again, we've talked about this. Always on remote services, work from home. Excuse me. VMware Horizon. Some of you, if you're like me, have been in the industry for a little bit. It was also called Horizon View. Is now called kind of Horizon. Horizon version 7 is the current version, and it's a capability to, again, do this VDI, virtual desktop infrastructure, accessing servers and systems remotely. And we want to do this load balancing because, number one, we want high availability. We want to make sure that these services are always available. We don't want any downtime. So we want that automatic fault detection of the unified access gateway, and we'll talk about the architecture in 1 second, and the connection servers that are part of the architecture for VMware Horizon. Number two, we want scalability. Before 2020, I might have had, 2%, 5%, 10%, 20% of my workforce accessing this infrastructure. Now in 2020, I might have, 80%, 100% of my employees accessing the infrastructure, and I need to be able to scale these resources quickly and easily by adding new servers and resources so that everybody can utilize this without having problems with latency and performance issues. Number three, we want to make this scalable. We want people to be able to access these remote desktop services, these VDI services, without having to go through a lot of hoops. They don't need to know different DNS names for the different servers. I don't need to know the VDI name to access my HR system versus my finance system versus my IT infrastructure, NetOps management system, whatever the case may be. And last, we do want some sort of disaster recovery. We want some capability so that if a site fails or something fails, we can have disaster recovery and automatically flip over, or in an active scenario, we can do it based on geography. So for a global organization, we can provide that availability and provide regional access based on your location and geolocation to send you to the appropriate data center and resources for that VDI infrastructure. So there's a lot of good reasons why you want to load balance. You don't have to, but it's strongly recommended. It's strongly recommended by VMware through their documentation that you load balance Horizon and the components within Horizon. So let's talk a little bit about what we mean here. Excuse me. So here we have a typical Horizon topology. This is what I will call my reference architecture. I have my Horizon clients on the top of the screen, and they're going through the internet. So I have a security device, whatever it is. And you see I have a pair of external load balancers in the middle in the top box. And those are in a HA, high availability pair. And they're then load balancing the VMware UAG, Unified Gateway. This is the authentication engine, as well as the central collection point, traffic management point for the clients to get to all the other pieces in the Horizon topology. And you can see on the left-hand side, then there's the vCenter. There might be Active Directory for authentication for the user's authentication system. And that's all connected. And then on the bottom box, I have another pair of load balancers going to my Horizon connection servers. These are the servers that actually make the connections to those remote desktops, to the remote systems to provide that remote VDI capability to the different systems. So we want the authentication to the UAG, and then it drives the connections to the connection servers. So we have two steps in the layering for a typical Horizon connection for VDI for these clients. Hopefully that makes sense. And for load balancing, you can see now we have two pieces we need to deal with, the connection servers and the UAGs. Excuse me. And first, we'll go through the connection servers. This is the easy part. We have this internal load balancer as load balancing the connection servers. And it's easy from a load balancing perspective because it's very straightforward. It's load balancing port 443, secure HTTP, HTTPS. So you can see I have a virtual IP address, in this case 10.10.10.103, port 443, protocol TCP for my VMware connection server. And I have two real servers, in this case 10.10.10, 101 and 142, that are the servers that I'm load balancing. And you can see also I have this port 80 configured for non-secure HTTP, and that's just for a redirect. So if I type in the domain name or whatever to connect to the server, and I did not put HTTPS in front of it, I'll get redirected to port 443, even though I originally went to port 80. So very standard load balancing, very straightforward, nothing fancy, just load balance a pool of HTTPS servers. So we have three use cases that we want to talk about when we load balance Horizon. And these three use cases are, number one, source IP affinity. What do I mean when I say source IP affinity? Well, let's take a step back. First, there are multiple ports that are used within Horizon. So when I make a connection, or when the Horizon client makes a connection to the UAG, it's going to do it on port 443, HTTPS, and it's going to be some sort of XML type connection in terms of type of content to do the authentication and get the user connected to the UAG. Then there are secondary communications going on. And these secondary communications could be HTTPS for some connections, for some multimedia, for remote desktop services, for some other pieces. And there's also two other key protocols that usually you'll do one or the other. One is called PC over IP, and this is the way the protocol to stream the display of a system to the client, PC over IP. And then there is a more proprietary technology called Blast for that VMware has created to do a very similar thing. So they do basically the same thing, and there are pros and cons. You can do your search of the internet. I'm not going to promote one versus the other, but these are the display protocols, PC over IP and Blast. So there's going to be a second connection going to PC over IP or Blast through the UAG to the connection server to these desktops. So to maintain some connection clarity between the initial connection that did the authentication to the second connection that's doing this HTTP, PC over IP, or Blast connection, we need to maintain some sort of affinity between the two to make sure that they go to the same system. If they go to different servers, then we have a problem where one server is saying, well, you weren't authenticated. What's going on? I'm going to drop that connection. So we need that affinity, that connectivity between those two connections. So the source IP address, the client IP address, is one of the more common ways, or I should say the most common way to do this affinity. But there are pros and cons. The pros is that the configuration is very easy for Horizon. Second pro is it uses standard port numbers. Port numbers in terms of port 443 for the HTTPS, and then the standard port numbers that for the PC over IP and for blast, and we'll see those in a minute. And you don't have to have multiple IP addresses hosted on the load balancer or on the public side of this network to make things work. The cons is that it relies on the source IP address of the client for the Affinity. So the problem here is that if we have two clients that have the same IP address going to the UAG, but there are different clients, the UAG is going to get confused. You're thinking to yourself, well, why would that happen? How would two clients have the same IP address? If you have a firewall that's doing forward NAT, for example, if I'm in an environment where there's a firewall that's doing a NAT proxy to the internet so that all the people behind that firewall look like the same IP address, then this is a problem. Or there is something called mega proxy, where in some hosted environments, some types of environments may be based on VPN technology, or the service providers might have something called mega proxy, where all of these clients behind all these people connecting to that service provider are going to look like they're going from the same address to the internet. So again, there is no uniqueness in the source IP. What we're trying to confirm here is that we need to make sure there's uniqueness with the source IP from the client, that no other client is going to be using that source IP because they were netted to the UAG, to this VDI Horizon environment. So source IP affinity, we have the client on top again. We have the protocols. We have here HTTPS horizon.kempdemo.com on port 443. That's the authentication. And then I put the IP address here, but it could be the domain name, 38.98.105.219. It could be horizon.kempdemo.com as well. And port 4172, which in this case is PC over IP protocol. So I have a client connecting PC over IP going through the load balancers, and I have two UAGs, 10.10.10.90 and 10.10.10.91. On the Horizon UAGs, the 90 and 91 servers, this is how I want to configure them. You can see, number one, I have the connection servers at the top that I've highlighted. Horizon-int.kempdemo.com, port 443. Those are the, excuse me, that's the virtual IP on the internal load balancers going to the connection servers. Then in the second box on the bottom, you see I have the PC over IP external URL, and that's this we just saw, 38.98.105.219, port 4172. I have a blast being enabled on port 443, and I also have a tunnel, which is that HTTPS protocol that I mentioned, also on port 443. This needs to be configured on both of the Horizon servers, and the configuration is going to be identical on both Horizon servers. On the load balancer, you can see now I have this AD redirect going to my UAG load balancing TCP on HTTPS 443. I have the two UAG servers load balance, 10.10.10.90 and 91. You can see on the right-hand side. And then I have the ports and protocols for PC over IP and blast. PC over IP being 4172. And you see here I've configured blast to be a unique port 8443. To make sure that I maintain that affinity between those different ports to the initial connection, which is going to be on port 443, I need to create some sort of affinity on the load balancer. So on the load balancer, I'm going to go to my options, go to my persistence options. This is on Kemp Loadmaster load balancer, of course. I'm going to create a persistence option mode source IP address. And I'm going to do that for the port 443. And then what I'm going to continue to do is I'm going to put advanced on all the other ports that I've configured for that load balancer. I'm going to do port following and say all those other ports maintain that persistence and affinity based on or follow that original port of 443. So all those ports, secondary ports that are being connected to on the load balancer, if it's the same source IP, we know to go to the same UAG. That's that affinity that we're creating. So now we can see on the load balancer in the stats, we have port 443, 4172, and 8443. All those ports that are highlighted in that red box are port following port 443, that port right above it, to those two UAGs on 90 and 91. This is how we're going to configure source IP affinity on the Kemp Loadmaster. One small last thing I'm going to change is, you see I changed that blast port to port 8443. I'm going to also do that on my Horizon server. So on the two Horizon servers, I'm going to go change that blast port you can see on the bottom to port 8443 as well to make it all consistent. So this is probably the most complex and in-depth description that I'm going to go through with this presentation on doing the load balancing for Horizon, to give you the most detail of how it's done, because this, again, in most of the use cases, this is how you're going to configure it. But then I also want to go through a couple other use cases. So let's talk about other use cases. If for some reason I can't do source IP affinity, here's another option. We can do multiple port number groups. So those secondary protocols, I'm going to create unique port numbers on each UAG. The pros, it does not rely on that client source IP affinity. So if I have that firewall NAT that I discussed in that last use case, then that source IP affinity will not be there. So we don't have to rely on that. Second, you still do not have to have multiple public IP addresses. So you're still only going to have one single IP address going to the outside world. The cons, we're going to start using non-standard port numbers. So we saw the port 4172, we saw the 8443, we saw the port 443. We're going to have to start changing those, because we need to create some sort of unique values for each UAG for those connections to maintain that connection persistence between that initial connection and those secondary connections. So here in this multi-port configuration, you see I have my initial connection going to horizon.kempdemo.com port 443. But now for my blast and PCO over IP, I have two sets of ports, possibly. Port 10143, 10243. And I have port 10172 and 10272. It's getting more complicated. The client needs to go to these other addresses depending. How does this work? Let's take a look at this. On the Horizon UAG configuration, we want to make changes. You can see and now we have two different windows, because we have the UAG, which was .90 IP address on the left-hand side, and .91 IP address UAG on the right-hand side. And we need to make sure that they're different. So you can see that the PC over IP and the blast and the tunnel port numbers are on the .90 server, 10172, 10143, 10143. But then on the right hand, which is the .91 UAG server, 10272, 10243. So that they are now unique and they're different. This is how we're going to maintain that consistency and persistency to the specific UAGs, is making the UAGs actually different. So on the load balancer configuration, you can see this is getting a lot more complicated. I had that port 80 on top and the port 443 on top. But now I have all these multiple ports on below it. Port 10143, TCP and UDP for blast. 10172, which is PC over IP, and that's going to be the one server. You can see those go to server.90, And you can see the real server addresses on the UAGs are actually the appropriate ports, 8443 and 4172. But the virtual IP is going to be different because that's what we're advertising. And then we have the 10243 and 10272 for the .91 server. This is for 2 UAG servers. What if I have 3 UAG servers? Well, I have to have another set of ports, 10343, 10372, and add it on. So if you had more and more UAG servers, this gets longer and longer, more complicated. So you can see it's more complicated and harder to configure, but you do get that affinity now without having to rely on source IP. There's a third use case here. The third use case is where we have multiple IP addresses that we're advertising to the internet. So all of these different use cases, the client with the affinity, client IP address with affinity, the second use case was doing multiple different port numbers with affinity. And here I'm using different destination IP addresses, which are the VIPs, the virtual IP addresses for affinity. And you can see in each case, I'm trying to create some sort of method to determine unique connections and maintain that persistence and connectivity. So definitely do look at that and try to understand. It's all about trying to maintain unique connection tables to maintain that connectivity and persistence between those different connections of the primary connection to the UAG for authentication and the secondary connections for that desktop service. So the pros of this third case, again, we do not rely on that source IP affinity, which is a good thing. The second thing is we are back to using standard port numbers, which is a good thing. The con is that I have to burn more IP addresses on the public side because each UAG is going to need a different VIP, virtual IP address. So if I have 2 UAGs, similar to this use case number 2, if I have 2 UAGs, I need 2 virtual IP addresses. 3 UAGs, I'm going to have 3 IP addresses, etc., etc. So we need to be careful about that. How does this look in terms of configuration? For the multi-VIP configuration, you can see here now I have my initial connection going to horizon.kempdemo.com port 443, which is what we had previously. That's fine. But now you can see here I have different IP addresses for my 2 UAGs. I have UAG1.kempdemo.com and UAG2.kempdemo.com. And I have the IP addresses listed on the PCI ports, which translate to port to .221 and .222. So this is how I'm creating that distinction to get the load balancer to work with these different UAGs. The one advantage is that I'm still going to one central horizon.kempdemo.com for my initial authentication piece. The disadvantage is that I'm almost really not load balancing per se, though I am providing some sort of availability and fronting the service of the UAGs, because now each UAG is basically being translated to like a firewall NAT through the load balancer. How does this look for the configuration for the Horizon servers and for the load balancer? Here I have my 2 Horizon servers, .90 on the left, .91 on the right. And you can see my PC over IP is going to .221. In this case, I'm using port 172. It can be anything. And I have my blast going to UAG1.kempdemo.com, excuse me, which is the domain name for that IP address. On server 2, on the right-hand side, I have my PC over IP going to .222, which is a different IP address. And you can see my FQDN, my name is UAG2.kempdemo.com. So that's my uniqueness that I'm maintaining for that persistence between the different UAG servers. And again, if I'm using a third UAG server, I would create a whole nother set of IP addresses or use another IP address, .223 most likely, and call it UAG3.kempdemo.com. and et cetera, et cetera. So this is how I would do things if I was configuring using multiple VIPs to maintain virtual IP addresses to maintain that persistence. So how does this look on the Kemp load balancer configuration? Whoops, wrong direction. Here's my configuration. Again, the first two lines are going to be the same. I'm going to the 219 on port 80 and 443 with that redirect for the authentication piece, going to my two servers, .90 and .91. And now you see I have standard ports again, port 443, 4172, 8443, but I have two sets of IP addresses, .221, which map directly to 10.10.10.90, and .222, which maps directly to 10.10.10.91 for the PC over IP and blast. So again, more complicated, probably about the same complexity in terms of configuration as the multi-port. But instead of doing multi-port, again, we're doing multiple public IP addresses, multiple VIPs, virtual IP addresses for this configuration. So a lot of technical detail, a lot of things that are easy to get confused on. So let's start summarizing and think about what we saw and looked here. And we can go through, review this presentation. And by the way, this is all documented within the VMware community. So if you go to the community website and look for load balancing VMware Horizon and look at these different cases, they explicitly call out these three use cases and all these things that we're talking about. We're showing you how it's done on the user interface basis and from the load balancing configuration basis. So summary. Number one, yes, load balance Horizon, please. And honestly, I'll end that. This isn't just for VDI. Load balance all your applications. All your applications deserve load balancing functionality because it provides that availability, that scalability, that resiliency, and that site redundancy for that disaster recovery. So load balance Horizon is a good thing. Number two, don't forget you want to load balance not only the UAGs, which is the more complicated part, the unified access gateways, but don't forget load balance the connection servers also. It makes sense to load balance each tier of that Horizon deployment. Point three, source IP affinity. As you can see in this presentation, is the easiest way to configure and set things up. If you can use source IP affinity, do so. It'll make your job and everybody else's job a lot easier. Again, there are situations, point four, where you can't use source IP affinity. And the way to think about it, again, the simple way to think about it is, am I going to have clients potentially with the same IP address coming to the same Horizon infrastructure? If the answer is yes, because I have firewall net devices or mega proxy situations where they're being added to the same IP address coming into the infrastructure, then you have to use one of these other methods. Source IP affinity will not work because, again, the UAGs will get confused with the two different clients coming with the same IP address. And if that is the case, you have to use multi-port or multi-VIP to make it work right. Which one you use depends upon where's your pain. Multi-port means you need to open up more holes on the firewall. Multi-VIP means I need to burn more public IP addresses. So I can't tell you which one of the second two are better. It depends upon your use case of which of those is less painful of opening up firewall holes or using more public IP addresses. But one of those is going to be needed only if you can't use that source IP affinity. So again, client source IP affinity is the easiest way to do it. Highly recommended. Load balance all the components in the Horizon deployment infrastructure, the UAGs and the connection servers, and load balancer applications in general. In addition, I also wanted to mention to you at Kemp, we have a technical preview program. We have some really cool things that we have available in terms of you being able to play and test. And this can help you also with your VMware deployment, because when you're working with your VMware deployments, you're probably going to be working with technologies such as Ansible or Kubernetes. If you're working in a containerized environments, or you're doing things in the cloud with Microsoft Azure, and we want to make some technologies available to you to be able to look at, play with, and also influence how we are integrating with these things. So when we talk about things like Kubernetes, we want to talk about things like Pivotal and integrating with VRO, VMware Orchestrator, and VRA, which is VMware Automation Engines. And we also want to talk about integrating with VMware Tanzu. So we want to put these pieces in place and make them available to you. So I highly recommend that if you're looking at Kemp Technologies, looking at Kemp Solutions, definitely look at our technical preview program so you can look at some very cool technology that we're working on and we're deploying. We have the Ansible preview program available, as well as the Kubernetes preview program available. You can see there it's available at the kemp.ax/tech previews. So I strongly recommend that you play around with those as you play around with the Kemp and load balancing technology in your environments. So at this point, I want to move to any questions. If you have any questions, feel free to pop them in the Discord channel and they'll come over to me here in this. And I'm more than happy to answer anything that you have. And of course, look at more information that you provide you more information that you might want in terms of the deployments and what we're talking about. So I do not see anything right now, but I'll give it another minute or so. And I'll also mention to you again, when we're talking about these use cases and the VMware Horizon deployments, this Horizon 7 deployments, is that it's a lot. We have full documentation in the VMware site in the communities and for how these different situations occur, as well as Kemp. And I also want to make a very strong mention in terms of Kemp. If you're deploying VMware Horizon, we have templates that make things easier for you. So all of these things on the load balancer side that I configured, we have templates that configure it for you on the back end. So you can download the Kemp VMware Horizon template, and the template actually has the configurations for all three of these use cases, for the client IP affinity, for the multi-port affinity, as well as the multi-VIP, multiple virtual IP affinity. So here I have a question coming in. The multi-VIP configuration allows for multiple ingress points to multiple UAGs via a single HA pair of load balancers. Nice. So it's more of a comment than a question, but I think it's great. But absolutely yes. So it does create that single ingress point. So you have those multiple UAGs. And that's kind of the purpose of the load balancer, is you want it to act as that traffic cop, that traffic director to the entire farm of UAGs. So you're not getting the 100% benefit of load balancing, quote unquote, per se, where it can balance the load across the different UAGs, because each one is now unique with its own VIP to a certain extent. But you do get the flexibility that everything's being fronted by the load balancer in front and the UAGs below it. And that makes it very easy for you, obviously, from a configuration standpoint, as well as an operational standpoint. Because if I want to add a new UAG, all I have to do is add VIP configuration on the load balancer and advertise. If I want to do some sort of management in terms of service control, I can take the UAG out of service, and the load balancer will automatically know that the service is not available. This is something that we didn't mention, for example, in this chat, in this session, is health checking. The load balancer is going to health check the UAGs and the services, and including the secondary services. So the typical secondary service will give a response back. For example, if it's HTTPS based, it will give back a HTTP 200K, status code 200. standard HTTP response. And that's what the load balancer is looking for. But you can tell the UAG, I want to go down into maintenance mode because I'm going to do some work on it. I'm going to change the memory. I'm going to do some other work, upgrade some software. So I can put it in maintenance mode. And put it in maintenance mode, then the UAG is not going to respond with that 200K. It's going to respond with the 503 server unavailable. And because it responded with a 503 status code, now the load balancer knows do not send any traffic to this server. It is not available. And instead, the load balancer can start doing things like redirect to an existing server that does work, or if it is actually truly load balancing like client IP configuration, it can actually just shift that connection to the other working UAGs. So the load balancer is very nice that it provides that level of abstraction between the clients and the UAGs, and subsequently from the UAGs to the connection servers. So you have the same flexibility with all those connection servers in terms of adding and removing and making those changes. So it makes it very, very flexible and nice. So if you have any other questions, I'll hold on for another minute. And again, I'll mention a couple things for the templates. The template is so easy. And this is why I or anybody, and I know that we are all VMware experts. I'm a Kemp expert, but you may not necessarily be a Kemp expert, for example, or a load balancing expert, and you need to configure this. You need to do in the lab, or you're actually managing it on an operational basis. The templates, I like to say, take the expertise and put it into the tool. So that template takes 80 to 90% of what you have to configure in terms of the port forwarding and the health checks and all the other pieces on the load balancer, so that all you have to do is make sure that you know what the IP address is and the port numbers and things like that you configured on the UAGs match what you configured on the load balancer, so that's all the same. And as long as you do that, all the rest of the configuration is going to be automatic. It makes it very nice. So at this point, I don't see any more questions. I appreciate everybody spending the time and listening to this conversation. Hopefully it was very beneficial. Again, I recommend that you do go to the Kemp website, look at things. You can download trial software available for free, and try this out on your own. And we have videos available on our YouTube channel, and obviously and there are things on the VMware site as well, showing you how to do this step-by-step interactive videos. So highly recommend you look at these resources. Come back to us if you have any questions, and I hope that y'all have a great VMware experience with VMworld and everything else. I thank VM Underground for hosting us and letting us present this information. And I look forward to seeing you all sometime in the future. So have a great day, evening, morning, and I look forward to seeing y'all sometime soon. Thank you very much. Bye.